Imagine you're a brilliant doctor who suddenly needs to become a lawyer overnight. You'd struggle with all the legal jargon and procedures, right? That's exactly what happens when we take a pre-trained language model and ask it to work with specialized content like medical records or legal contracts. The model simply doesn't know the domain-specific language and patterns. Traditionally, we've solved this through two approaches. Domain adaptive pre-training, where we retrain the model on massive collections of domain-specific text, or task adaptive pre-training using smaller, focused datasets. Both methods work well, but here's the catch. They're like renovating an entire house when you only need to update one room. We end up retraining every single parameter in the model, which is incredibly expensive and time-consuming. Here's what the researchers found that changed everything about tapped efficiency. Think of a language model like a two-story house. The ground floor is the embedding layer. It's like the foundation that converts words into numbers the model can understand. The second floor contains the encoder layers. These are like well-furnished rooms that already know how to recognize language patterns from the original training. The breakthrough discovery was this. During tapped, you only need to renovate the foundation, not the entire house. The upstairs rooms are already perfectly furnished and don't need changes. So instead of training the whole model, researchers found they could freeze those encoder layers and only train the embedding layer. It's like remodeling just your foundation while keeping all your furniture exactly where it is. This simple insight slashes computational costs dramatically while maintaining the same performance benefits. Now let's see how the researchers put their theory to the test. They chose 4 diverse datasets to really challenge their approach. Think of these as different testing grounds, each with its own unique characteristics. First up was IMDb, a massive collection of 50,000 movie reviews, perfect for testing sentiment analysis. Then AG News with 120,000 news articles sorted into 4 categories, followed by Emotion, which analyzed Twitter messages to detect 6 different emotions from 16,000 samples. Finally, BBC News offered articles from 5 different domains with 16,000 samples. Here's where it gets interesting. They ran 3 different experiments, a baseline with no special training, standard TAP-T that modified all layers of the model, and their proposed method that focused only on the embedding layer. This systematic comparison would reveal whether their targeted approach could outperform the traditional methods. Now that we've seen how TAP helps models adapt to new domains, let's explore what happens next during fine-tuning. Think of fine-tuning like teaching a student who's already learned the basics of a subject, but which parts of their knowledge should we allow them to update? The researchers tested 3 different approaches. First, they let the model update everything, all its layers and components. This worked best, like allowing a student to revise all their notes. Second, they froze the middle processing layers, but kept the input embeddings and final output layers trainable. This was almost as good. But here's the key finding. When they froze the embedding layers, essentially preventing the model from learning new vocabulary relationships, performance dropped significantly. This tells us something important. Even after domain adaptation, keeping those word embeddings flexible during fine-tuning is absolutely crucial for the model to perform well on specific tasks.